but nobody else. So any other questions?
Don, can we do screenshots? Is that okay?
Oh, and sending them to me or what?
No, so I can take your notes.
Oh yeah, you can do anything that way. Yeah, yeah.
Back up a second, because you went over the one on the Chromebooks really quickly. What's the idea on Chromebooks that they can use?
Well, they use Trinket, and
Trinket?
It's actually, if you look at the sheet that I have the website, a link to it on the setup sheet that I gave to you. As I said, okay. Now, other things that I would just recommend. I was fortunate enough to end up working for College Board and doing a whole bunch of junk relative to all the AP curriculum and stuff. And I did a whole lot of workshops. And so therefore, I've been fortunate enough to work with, thousands of teachers working with that and talking to them about kids and everything else. And one of the biggest things that I saw students struggle with when I was doing, I taught in Korea for a while, and I would fly back and we would do AP prep things for a week, 6 hours a day for their spring break. They would come in and if you know anything about Korean, the Hagwon system, I was light. I was easy compared to their normal Hagwon junk that they used to do. And so, and a lot more effective, I think. So working with a lot of people and stuff, one of the biggest mistakes I think we make as teachers, and textbooks most definitely make, is that we hand way too much stuff to people at the beginning. Therefore, real life doesn't work that way. You don't get paid the bucks that we get paid to be engineers and CS and programmers to solve problems that are already solved. Whenever we're given an issue, it's like people don't know this thing, or else they don't know what the answer is, because they're not Microsoft and they don't buy the companies that solve the problem for them. They're not of that nature. So therefore, but when we teach kids, think about your textbooks. They open them up and they say, here is this. This is the way it works. These are the problems. And then you walk into it. And then you take an AP test. If you want just to have fun, even if you don't do computer science in a masochistic way, fun, look online, the College Board, and look up the AP test questions, the free response Java questions. And by the way, now it's the easy Java because we only do A rather than AB. Go back and look at history and look at the AB questions. Being on the committee, it was interesting because our job was to make 4 tests, complete tests every year. That's one of what we were paid the bucks for. And there were 3 high school teachers and 5 college professors. So I had to take 7 tests 4 times a year. And I would think, oh, I'm going to get pretty good at this. Oh, Lord, every single time I took somebody's test question, they put up a question and I went, what, who, and I had to figure out how to attack this, because our egos are pretty easily bruised if we go under a group of college professors, and I'm from Salem, Oregon, and they ask them questions about electricity out here and stuff like that already. And I say, I want to make sure that they think that I might be appropriately placed in this group. So no, I ain't going to walk in like an airhead. But I was astonished that I was constantly surprised with the problem that I had to solve. And kids have the same way, but yet if you think about the way we teach content, they never face that issue. They don't come up to that very often. So the way we teach, I call it the intellectual leap. I wrote an article about it. That's the type of stuff we need to set up as we're instructing, even from the very beginning. Mike and I spent a lot of time. I think computer science, I'm math and English major. Those are my degrees, which is a little twisted in and of itself. But the fact came out to be is I love teaching computer science because I could teach physics level thinking to a freshman. And I couldn't do that in any other subject matter. You can't do that. You can't teach physics to a freshman because they don't have the science, the mathematics, they don't have that. But I could teach that same level of thinking in computer science to a freshman, and a whole class of 30 kids at North Salem High School would nail it. And that's because we set that up. And that's part of what I'm going to instruct. And so part of that, what I would like you to do, if possible, if you printed out the documents that I sent, especially the coding and the other stuff, literally fold the sheet over so you are not looking at the stuff ahead of time. As soon as you see an answer, that spark is gone. You can't do it. You can't get back to that level. You got to start from scratch and go, what do I do now? And that's what we have to get to our kids. And those are the ones who are phenomenally successful at job interviews. If any of you have ever interviewed I worked for Google for a little while, and all of those interviews were insane. I was astonished how hard and how quick I had to think on my feet in the midst of those things. And I think all of us here would be great, because as teachers, that's what we have to do every day. With the classroom of 20, 30, 40 students, we have to do that. And so in reality, we're the best prep for those type of job interviews. But that creative spark is what we have to kind of teach our students to get to. And we can do that if we do this same thing right now. That's part of it. All right. And second thing I want to share just before we get started, some of you, and probably not, I'm old, so none of you have, but there was a professor at Willamette University, Mike Dunlap, who was a great guy. I never had him from classes, but he taught several workshops. And then there was another guy, you may have read his books, even Tim Budd, who was object-oriented stuff at OSU, wrote a whole bunch of books out. And he was a good teacher, but he was a little bit more in your face about some things. And he came to a workshop at Western Oregon when we did OCS down there. And both of them said the following, in radically different styles, that they really didn't want anybody to teach computer science at high school or middle school. And I went, what? Here you're sitting at a conference with 35 high school teachers and a couple middle school teachers in the day, and saying, you don't want us to be teaching what you're doing. So I said, hold it. Mike and I had the conversation, and but with Tim, I just, hold it, stop. What are you talking about? And Mike, they had said it in two different ways. Mike said the kids at Willamette, he could tell who had had high school programming because the number of years of experience was inversely related to their grade in his class. The longer they did coding, the worse they did at computer science at Willamette University. And Tim said it even more directly. He said high school teachers screw up kids. They completely mess them up before they come to OSU to do computer engineering and electrical engineering. And I said, well, this is a stupid thing to say. That would be like going to high school and saying, we don't want you to teach them math. No calculus, we don't want that at high school level because it's just dumb. We want to wait till we get here to teach them. And you go, now, tell me why, tell me what's going wrong here, and we can fix that rather than saying no. And he said, because kids play with computers in high school. The wrong approach, and everything I'm saying is editorialized, so you can completely disagree with me, and we can have great letters going back and forth if you want, but I tend to agree with, we use project-based learning, and we use it in the completely wrong way. And that is, we just throw something out, and this is what they said, kids who come to college think they know how to program. And what their thing is that a teacher just hands them a problem and says, I'll be back next week, turn it in. And the kids don't know anything about efficiency. They don't know anything about style. They don't know anything about readability. And the kid, and you guys know it, the guy, and yes, I am being specific here. I don't think in the 40 years of teaching I had, and you can scream at me, whatever, but I don't think I had a single young woman ever do stupid things. I would have the best, beautiful, non-working codes turned in by guys. They would just be beautiful screens and graphics, but they didn't do the problem I gave them. They didn't solve the problem. Or they solved the problem and they were complete trash. They were pitiful code. And I said, well, then what's the solution? He said, well, we have to teach them efficiency and style and using the right tools and all that stuff. You can't just say solve this problem and back away and let them be. They don't know how to do it. And since I've been working with teachers a lot lately, there are some expensive packages out there for teaching Python and teaching Java that completely suck. They are the worst things I have ever seen. I don't know No teacher, it must be like most math standards, they are made by some college professor who has never ever taught high school kids or middle school kids, and they don't know what they're talking about. And yet they're telling us what we have to do to teach. And so therefore we have to teach. And that's what I hope as we're doing this couple weeks. Half of the stuff that I think is pedagogical stuff as well as it is syntactical stuff. And I'm going to be introducing some of those things. And those are the two pieces I think you got. Number one is we got to get that creative spark. I call it the intellectual leap. You got to set that up, and we can do that with our first codes, not waiting till we're doing binary search trees for them to see it for the first time. We need to do it at the beginning so they learn to take that leap.
So,
Number one, it's a whole lot more fun for them. And number two, that's what they got to do all the way up the line.
so
Yeah.
Don, I'm going to interrupt and moderate just a little bit this discussion, which is fascinating to me as a mother and a tech person myself. So we have a question in the chat that says, so the solutions, right? They're available all over the place. On Google, kids can go look up solutions all over the time, all over the place. How do you set up your classes to convince kids not to do that?
Well, in
What do you
all honesty,
tell them?
well, I think it goes with our instruction here. If they get the juice, the fun of programming is not the answer. The fun of programming is solving the problem. But if you think the way we teach, the way online expensive packages teach, is they take them by the nose and lead them step by step, and sometimes in really circuitous, stupid ways to get to something. Whereas if we teach by giving problems, and I'll show you examples of that, it's even more so in the second session and the last parts of the Wednesday session, the intermediate problems, but even here, we'll talk about it. If we give them problems, they get the juice. Computer science is the funnest course possible because you have immediate reinforcement. If you do it right, the screen gives you the answer, or if you do it wrong, I got to do this. But they won't be taking their time looking up answers because they're having fun solving the problem. That's the difference. And that's how we got to that's the way we teach it. Not the way, and there's nothing online that I have seen. And if any of you guys have found a great package, one that you really like, please text, put it out in the chat, because I've helped multiple teachers and worked several things. I have not found a single one that I thought was worth 5 cents, much less $5,000, which I've seen people pay. So please let us know. So those are the two things, the intellectual leap, number one, and then two, we've got to teach them how to think. And that leads me to the following, my intro cartoon here. Everybody seeing that now? But there was a little bit of delay on mine earlier, I know. This is an old Far Side. I think this is what our job is. This is what project-based learning is really about. The sheep will get there, but we have to know where we want them to end up. And if we do this right, yes, they are independent. They can go a whole lot of different ways, but I know where they need to get to. And if they're running over a cliff, well, oddly enough, I always used to tell my students that one of my jobs I saw, especially our bright students that we have, one of my jobs is to build walls. And they said, what are you talking about, Kirkwood? I said, I don't want you to get to Cornell and well, think about it. All the people at Cornell they were big fish and little teeny ponds. And now they get their first C or D that they've ever gotten in their entire life. They had never seen anything but an A. They didn't know there was anything else in the alphabet. And they do not know how to pick them. They run into the wall and crash, and they don't know how to pick themselves up. They don't know what to do. You guys ought to look at the suicide rates. I did this several years ago. You ought to look at the suicide rates in our real highfalutin universities. And it is beyond what it should be. And the problem is that these kids have never been challenged before, and now they really are. So my job is to build walls when there's somebody that's carrying around them. I don't want them going 100 miles an hour running face. I want them to stub their toe with me there, so it hurts and they learn to avoid that, and or they come to me or others in the class, their peers, and figure out how to avoid that and climb over the wall in the first place. That's our job. And so I think that's what project-based stuff can be phenomenal. And Mike taught, we used to do our senior year. It was insane what the kids did, but it wasn't like, have fun, see you later, solve this problem and get it back to me next week, because that sucks for every part of the possibility. All right.
So Don, we have a couple more questions coming in the chat, and I will encourage you all to actually, when Don takes a breath, to interrupt. And he's very conversant. He loves being in the classroom. I've seen.
Well, I mean, I can then interrupt
awesome.
and say mine.
well, yes. So Michelle had a question. So Michelle, go ahead.
Well, okay. I'm an engineer. I am not a natural programmer. And one of these things that I'm taking these classes for is to teach myself coding and programming and computer science. I don't want to go back to college and take all of this stuff. And basically my son, who's going into software engineering, he doesn't talk to me anyway. I just can't, online, I can't find where to start. You know, you're saying there's all these packages and all this other stuff. For me as an adult, I'm looking around going, I don't even know where to start to get myself this background so that I can bring it then into my middle school, put it in my engineering project-based learning, which I do. And yes, my classroom is set up to fail. And the kids know that and all that. But I just don't know where to start to learn myself.
Well, two things. Number one, I think this is a great place for what you're alluding to this session, the Tuesdays, when I do the graphical, and we'll start that immediately here, the graphical introduction of Python. I use this for fifth graders. I use this for a middle school computer club. And I use this to teach my intro to AP computer science. What we're doing here is, and if you start using this, then you can also go straight to Python's. Python has a whole bunch of files and like a tutorial structure that you can use straight Python stuff that would, with your background, you could pick up and do. I wouldn't spend a bunch of money for packages. And there are several things online for someone like you that, not like a kid who's learning this stuff. I mean, when we were in college, most of us didn't learn the stuff from a college lecturer or a math professor who unfortunately was brilliant, but not very good teacher. We learned it by cramming together with ourselves and looking at the book. Well, we can do that. But a high school kid, that's not where they are and not what they should be.
Yeah, well, I'm going to show my age. My last programming class was Fortran.
Oh, I used to teach it. Yeah.
Yeah. And I can't stand programming because I spent 5 hours trying to find it on a dot matrix printer and my comma versus period. Yeah. So I've kind of got this mental block, and that's why I'm doing this.
Yeah, you'll love this. It's radically different than that now. It's so fun to have taught computer science since '78. And where we are now is so much more fun to teach.
So no more TRS 80 color on my, okay. But so maybe offline later on, I can send you some emails and you can shoot me in the right direction. That's the problem, is there's just too much. I don't know where to go. Yep.
All right.
So can I, how do I interject? I mean, do I just do that?
Talk, I think that we'll just do like a classroom, or you can do chat and Kathy can kick you in right now while she's here. But yeah, go for it, Mike. Yeah.
So I'll just raise my hand.
Yeah.
So
like you would never do that in my class, but anyway.
There's a thing called W3 Schools online, and I think you just put your, like if you say Python, www.python.w3schools.org, I think it'll take you to a Python classroom. And also, I don't know why this is, but our generation, well, you know, I'm in my 60s, so my generation doesn't seem to like to use YouTube, but YouTube is a incredible source for this. And you can find some really elementary videos that show you how to do it. And they walk you through installation, they walk you through everything.
Okay, yeah, it's just narrowing it down, because there's so much information. You know, I'm still one of those, you know, hand me the textbook, here's the one thing you're reading, as opposed to try to sort it all out and filter it from everything out there on the internet.
Yeah. Oh, I picked the prettiest one. I mean, I really do. I let my eyes fall on the one that grabs my eyes, and then I watch it. And if I don't like it, or if it's not working, I just leave it and go to a new one.
You know,
And I don't mean that facetiously. I mean, that's
Mhm.
really, YouTube is a huge source now. And I don't know-
Rajani brought up some stuff about Code Academy. There's some problems there. Yeah, maybe we'll do it this way. I would, if this was a normal classroom setting, when Mike has been, when we had 3 to 5 days with 6 hours a day doing this stuff, this conversation would continue on for 15, 20 minutes,
Yeah.
half hour, and be 100% appropriate and do it. Since we have 2 hours for 4 weeks, if you don't mind, those type things
Oh,
would be great for the chat to put them down there, because then you guys can see that and answer each other, and you don't need to pay attention to me anyway. And or we can respond to them later in this big old share. Because yeah, Code Academy has great problems. I don't always like their sequence, and I don't like the way they hand things to you. There's a whole lot of places out there that you can steal from, and we as adults can learn from very effectively, I think. Ironically, I think they're better for us than they are for kids.
Yeah,
But-
they're made by educators, so they don't work
Yeah.
for kids.
Yeah. So, all right, so I would like to get started in this Python stuff, if that's okay with people, and you guys share that way, and I'll just watch your eyeballs and nobody paying attention to me, and that's cool. So we'll just do it that way.
Don,
All
can
right.
I interject one more thing before you start?
No,
Well,
no, Mike,
I just wanted to.
I know Mike well. Sorry, guys, that's why I can do this.
I just wanted to say to people, consider if you want to play with this and practice it, consider installing an IDE on your phone. And I use open source because that's what I like that. So I have a Samsung phone, but if you have an iPhone, if you have whatever phone you have, phones software is designed to make everything really easy, least access for keyboard stuff. So if you're doing programming, the phone gets rid of all the pathway crap because it's all built in. So if you install on the phone, then you can instantly start to write programs, and you don't have a lot of issues with pathways and things. And and then you have it with you all the time. So that's it.
Okay, what I'm showing you here, now you guys are seeing the screen, I think, right? Everybody, that's the,
Yep.
and I'll have to talk to you, Kathy, since I don't do Zoom meeting stuff. It's hard for me to know what you guys are seeing versus what I am, but here we go. Our first goal, and literally, when I teach 5th grade stuff, when I was doing, I was going into low socioeconomic grade school here in Salem Kaiser, teaching 5th grade twice a week, working with a group. And I use the same kind of introduction. When I did the computer club over at Claggett Creek, which is once again a low socioeconomic middle school, doing a computer club, this is where we started, and we did stuff. Now, of course, the questions and stuff are radically different relative to what we got going on, but this is what I want to start with. I want us to produce this. Okay? And I want to, that's literally the very first thing I show the kids. This is what I want to do. So now you tell me, and you have, by the way, a copy of this. If you look at your sheet that, yeah. You guys have this sheet, how it's going to occur, right? You have this sheet there that I called intro session outline. If you had that and you fold it over, you got that same picture sitting in front of you right there on the graphic. If you printed it out, you've got it, or you can see it with the stuff, the material I sent to you.
I did have this.
Now, I want to create that picture, right? That's the picture I want to create. So what do I do? What do I do to make that picture occur? Now I'm going to kick over here and get us on the board. Kathy, let me know, are we getting?
Yep, I still see you. Are you switching to the second camera?
Yeah.
Yep,
I have
not
to
yet.
stop. You got it?
Not yet.
Okay, I have to stop sharing and for me to do this. Yeah. Okay, just a second here. Yeah, I'll get it here. This is the part that I don't do very much here. So
I wonder if I can do these things without.
I don't want to share. Yeah.
Can we import Turtle?
I put that link, that Google Doc link in the chat if someone can't put their hands on it right away.
Well, they were, they were all on. I sent them to you guys earlier,
Yep.
but there we go.
There we
Now-
go. Camera 2, check.
All right. Now, so, and be careful. I always call it, I have a metaphor for my students called one bite of banana. And I'm not going to go into that specifically, but the idea is And it's a lot more fun when I actually use this joke or this story. But the idea is, if you want to eat a banana, you take one bite, chew it, and then swallow it. You don't cram the whole banana in your mouth. And unfortunately, that's what students do with problems all the time. So therefore, we need to take one bite of banana. Tell me how we are going to make that picture on the screen. And careful, take the first bite. What's the very first bite I'm going to do to make that on our screen? Talk to me.
Well, we need to draw one line and then we need to draw a square.
Okay. Right. Well, all right. Now, in reality, I think probably 95% of the people who have answered this question have said exactly that. And it makes sense. But I'm saying you got a little bit of banana stuffed up your nose right now because that's not where we have to start if I want to draw that picture. If I'm literally, and I call it hands-on with my students at school when we do this, I say, you got to solve this problem as if you don't have a computer at all. Because if you can't solve the problem, there's no way you're going to tell the stupid machine how to solve it. So what do I have to do? If I'm going to draw this picture, what do I have to do very first? Before I have a square and a line and, yep, you're all right here, but before that.
And have something to draw with. Yeah. Something to draw with.
Something to draw with, and I have to have something to draw on. Right? I have to have that stuff. So I've got to get my screen. I've got to get my piece of paper here ready to go. Correct? I have to set that up. Well, in Python, what we end up doing, it's really nice. Python has, and if you look at your code stuff, if I have all this stuff, here we go. I got too much stuff on my stuff here. If you look at the coding things, and once again, please try not to look ahead. Is everybody now seeing on your screen zero template, number 0 template? This is Python's process. And matter of fact, this is one of the very few things I want to hand the kids because it's quirky. And I tell them to save this because anytime we want to draw something, we're going to do this. And I say, don't worry about the commands, they're a little tweaky, but this is what we've got going. And for those of you who've done coding, this is kind of cool because you're beginning to understand what's going on and how Python works. But this is the template that we will use to draw anything. This is our piece of paper and our ink pens. That's what we've got going here. So we start off with this, and I'll skim through it real quick. Like we import turtle. The cool things, those of us really old, there used to be a thing called logo way back in the 60s and 70s. I went to a program down at OSU called Smite. Then I said, oh, this is stupid. But it was insanely high-level mathematics using logo. It was the coolest thing in the world. And it was a special, and I love it. And they use turtle graphics. Well, Python just stole it. And because it's so simple and easy and effective. So why not? Now, by the way, Python has a way more advanced, faster, prettier graphics package used for professional development, but that's not where we are. So let's use the tool that we got. So we import turtle. And that's the part that you have to make sure you have all the links set up together. Mike, we're struggling on, you have to make sure the IDE and the stuff you have has got the correct links to Python's turtle graphics, because that's what it does, is import this whole library. And I've given you a command sheet. If you printed out the sheets, I would highly recommend that, like I said, to print out the documents that I gave you so you can just kind of have them in front of you and jot your notes on them and stuff like that along the way. So import turtle, and that next line, the hashtag is a comments line. I put import random because frequently we're going to use random in our programs graphically. So I put it in the template so that if in the future, I just have to get rid of that hashtag and we got it. Then we have the following. In Python, I need to make that sheet of paper. I need to do that. Well, Python says what we want to do is we want to create our window, our sheet of paper, our screen that we're going to work on. And the way to do that is to do whatever you want, whatever you want to call it. I just call it WN for window equals turtle dot screen. And the case, Python is case sensitive, so you need to make sure you do it. And it makes sense relative to several things. Those of you who've done object-oriented coding, you're seeing that if you do this, there's the other side benefit is that if you take the Wednesday class and we get to that stage for classes, we'll be going over it, and you're seeing some of the syntactical similarities between C++ and Java and other object-oriented languages in what, that's the other beauty of teaching Python. You can go way up into doing some advanced stuff. That's what I do in my pre-AP class. So this sets up the screen. And then what it does is in my window, once I have a window, it's just kind of, I want to make it, in this case, light green. And in the help files with Python, you can look up Python, and there's tons of colors. And the cool thing is that you can use numbers, but you can also just use words, and the kids can play with this all over the place. So we have now made a screen. That's why if you look at the little graphic that I gave you, it is in light green. Then what Python uses as a pen to draw with in turtle graphics is a turtle. So I'm creating T1, my first turtle, and the way to do that, T1 is a turtle, is in turtle graphics, and it is a turtle. There's some other images you can use there. So that's what T1 equals turtle.turtle. It says, go to the library turtle, little t, and create a turtle, capital T, because it is an object. It is a beast, an entity. And then I make T1's color blue. And I make T1's pin size 5. And if you look at the command sheet, I gave you a command sheet, or you're sharing this, not screen things. Well, I can put it there. I have given you a command sheet like that with all the turtle graphic commands. So later on, one of the homework, if you have time and or inclination, you can play with all this stuff and mess with all those commands and do some pretty phenomenal things. And then I always do window exit on click, because what I want to do is I want you to see that when you hit the exit button, if you just click your mouse, the thing will close off and do it. Now I will run this thing now, and I will show you what it looks like. And we will, I'll stop share here a second. And then, I probably should have just gone straight in the other way. I want to go over to this screen. Are you now seeing the code?
Yep.
So on the code, this is literally the template in Python. So all you need to do is run, and we run the module or F5, whichever way, and it is going to take some time to do some things. Okay, I'm gonna leave my screen. I've got so many things going here. No, it's not responding. How nice. I loaded up everything. It's not responding now. Just a second. It'll take a second to get going here, I think. There we go. And there's what we've created. Yours would go a lot faster than that, because mine stopped responding because I loaded this thing up at 9 o'clock. So making sure I had everything ready. But there's what we've got. We have our green screen, we have our green piece of paper, and we have our blue pen ready to draw. Everybody with me?
I've got a question.
Yep.
I tried to do everything I was supposed to before the class, and so I tried to copy and paste your code into mine. And I don't have an option to run. Right now, my thing looks like yours, where it says file, edit, shell, debug, but there's no run. How did you get that?
Okay, there's no run command?
No, like what your screen was right before you click back on it.
Oh,
that's
okay, I'll
not
go
mine.
here. Let me see. You have that
Yes, that's
option.
what I have.
Oh, you went to the shell. Yeah. When you got to the beginning screen, let me see. You loaded up. You have to open up the file first. Did you open up the file 0 template?
Yeah, yes, the Google Doc that you sent, I had that open and I copied and pasted it.
It's not a Google Doc. You have to go to the now I understand. You have to, and we'll talk about this more later. You have to go to the files, not the documents. The .py file where I separate each one of them out. And if you go that, what you end up doing here, and I'll close this off. Yeah, I'll close that one. And I'll go to another one, but I'll open this. So I'll show you. You go File, Open, and you got to get to the PY file where it is. You'll see just these files. Are you guys seeing the screen, I think? Right, everybody? and you got to go to 0 template. And when you click that, you will then, it will pop up to the non-shell, the executable screen, and you'll see the run pop up.
So
You did
is
not
there-
have,
So yeah, I obviously I did not do the right way, but I tried to make the link for Python, like, so that on my desktop I have a link for it. And when I open that, is there a way to set it up so that it would be not the shell?
no, it goes to the shell first, and then you have to open the file specifically. So you'll have to traverse through, I don't know what you've set up your, your sequence. Yeah. And actually, if you could do this, put it down, and we'll talk later outside of this, and we'll talk about executing, because you can actually see this and run it and everything else in the 2-hour session. Unfortunately, I think we need to kick here. So
Okay.
if you have issues relative to execution, you can chat to Mike right now. Mike can probably walk you through it while you guys chat personally back and forth, and/or you and I can talk after we're finished in 2 hours, if you don't mind.
Thank you.
All right, sorry about that. Yeah, if this was a regular classroom, once again, 6 hours, 4 or 5 days, we would do this. But yeah. All right, any other questions relative to just the template code? Okay. Now, going back to this stuff, what do we do next? Now that we have our screen out here, what do we do? Now, what do we do? I've got my piece of paper and my pen. It's all ready to go.
Oh, we got to move the pen.
And do what with it?
Draw
It's got to be a draw.
But draw what?
a line.
Okay, listen. So what do you got to tell me? I've got my pen right there. This is what we saw on the screen. Can everybody see that fairly well? It's
Yeah.
hard for me.
You got to tell it to move from point A to point B.
So you got to take this pen, and if you were telling me, well, that's great. I love my wife was a primary teacher, and I stole everything from her. It was just fantastic because they really know how to teach. And the kids, I don't know how they do it with 30 kids in the classroom, but they really know how to do it. So I always said, think that way. What do I have to do? If I'm drawing, I'm here, and you have to tell me to do what?
Move from point A to point B.
So you could tell me, and now you're doing algebra, we're doing that. Actually, there's a way to do it, to go from this coordinate to that coordinate. We could do that, correct? And that would work. But I hold it, I told you, matter of fact, I actually taught this to 3rd graders for a while. I was doing some stuff there, and we ain't gonna be doing coordinates, or they're not gonna be getting it. Even 5th graders, that's a struggle. So and that's 100% cool, we can do it. If you look at the Python thing, there's a way to do a go to and move right there. But what would be an easier way to take that and draw that line?
Choose a direction and choose a distance.
There we go. Because if you'll notice if you look at that little screen, when we make a turtle, it is directional. By the way, if you're with low-level kids, you might actually even want to change that turtle. They actually have an icon of a turtle. So it's kind of cool, and it's got the little nose. It's a lot easier to see and know the directional sense. This direction does matter on this. So what we want to do is just go, you just want me to draw forward a certain distance, correct? And that's all we need to do. Well, how do I pull that off? Well, if you look at the command sheets, you got it. Or if you look at so you fold this up and look at we could draw one line, and then what would I have to do? I want to backtrack this today. I'm going to do it a little quicker. After I do that line, what do I want?
To turn.
I want to turn. Which way and how and why, and what do you think is most logical?
Degrees.
Turn degrees. So if I say turn 30, it's going to work?
Positive or negative?
Okay, that would be one way. But think about kids. Think about lower level. Positive, negative.
Right or left.
Oh, there we go. You can turn right or left, right? Let's just make it right. This is what the cool thing. So my turtle right now is there. And I want to go right. How much?
90.
Everybody feeling good? Everybody see it? So therefore, I'm going to turn 90 degrees. So now my turtle is there. And what do I want?
Another draw a line,
Okay, and then,
turn 90.
right? And that would produce a square, which is what people verbalized as the first. Now, by the way, the cool thing is when I do it with the classroom, there's tons of different ways that this has come up with kids. And there's a whole lot of right answers. And we can do it, but you as a teacher knowing where we're going, later on, I let my students screw it up. I'm really sadistic. My students say that many times in many ways. But the fact comes out to be is that I let them make mistakes and let them go. Sometimes when one of my advanced projects students, literally we would be 2.5 days into this advanced algorithm doing some stuff, and they go, but Kirkwood, this won't work. And I say, why? Well, because if we did this, we would have to now do that or that. It would be a whole lot more work, and we can't. I say, oh, what a shame. And they go, but hold it. What do you mean, what a shame? What are you talking about? I said, this is, you guys were taking us here, so this is what we got. So where do we need to backtrack? And when we did this 2 days ago, we would have needed to do this. And I said, well, why didn't you know that? Well, we weren't thinking of, I said, well, golly gee, what should you have been doing then? Now we can do that later on. Right now, we don't want to smack them around. Well, maybe you do. It depends on your class. So it depends how well you know your students. But the fact is, right now, we're not going to. So what do we want to do? Look at your code 1 square. And are we looking at that screen? I can't remember what screen we got
Nope,
to. With you guys.
still on camera two.
Internet. You guys have it on the other place, and I will now share that screen. There we go.
So Kirkwood, so I take a little issue with what you just drew because one of our attendees said 90 degrees, and I went up and not down. So
Good. And by the way, like I said, there's other alternatives. That would be a completely legitimate solution.
Right.
And so you could, that's why I say in the classroom, if we had a regular classroom with more time, you could sit and discuss those. As a matter of fact, I'd want that. I'd say, is there other alternatives? And we do it, and we say, is there a better answer here? Well, we would discuss, we say, no, they're all cut. They'll all end up working okay. And I say, so what do we, just for us together, we'll choose one of them right now. You could go back and do it the other way. But in this case, it would probably not make any difference. We'll find out. Okay, good. But is this, yeah, question?
Don, I have a question.
Yeah.
So is there anywhere in the code that you're showing us how we would initialize the position of that turtle?
Good point. For kids at the beginning level, I don't worry about that. The fact is that it will go in the middle of the screen and you can start the turtle wherever you want to. So there is, and if you look at the syntax, the command sheet that I gave you that, if you look there, what could we use for that? Skimming through your command sheet. See, there's a whole lot of, there's set XY, there's, you have a lot of different variations that you can move your mouse to your turtle to a different spot. And yes, so you could do that. In this case, we don't tend to worry about the directional sense at the beginning. I'm teaching this as if I'm doing it to my 5th graders or at this stage in time. But yes, you can. All right? Now, if this, we'll see if,
is the default then the middle of the screen then?
Correct.
In the way that we've
Correct.
written this? Okay.
Yep. So now if we okay, if you look at your new one, there is square. This is number 1 dash square in your code. Don't look past that if possible, because we want to once again create that spark, figure out what's going on. And if we run that thing, there it goes. If you saw it executed, actually you see it draw that square. Everybody with me?
Yep.
Okay. Now on that, there's also a little command that later on we'll introduce, but I'll show it to you now. You can actually make that do a lot faster. I kind of like it at the beginning to see it, and I'll do it one more time here. I like seeing it run. You see it draw so that you see, yep, That's what we that's what we did when we did hands-on, and that's what we want. But gradually, as we get this more complex, it is a lot easier. Oh, shoot, sorry. Power mouse, there we go. I'll go back to Python, you'll see it down here. There's your beginning screen, and there's your phone.
Hey, Don.
Yep.
Could you make that full screen? Is that
Yep.
I think I'm looking at a little teeny window. If you can make it full
Okay.
size.
Yep, there we go. Okay.
Oh, and a good question in the chat. If I copy and paste it into the shell, why is it not working?
Copy and paste. Oh, you can't copy and paste, you have to open it because it's got to be a PY file, and copy and paste is a document. And I kicked you the PY files in both this morning I kicked it in a zip file. I also put it independently, and I also put it in the folder under code, not under documents. There's two little things. One's called code and one's called documents. You need to do the code one.
So I'm sort of confused, like, I'm still kind of stuck. How would students type in code? I can see you giving us code,
Okay.
but like if you can't copy and paste and you can't type it in, then aren't you just giving it to them? And how does that work?
No, you can, because I took off there. You can, if you do this, and you're getting syntax, and I was doing that, but that's cool. Here we go. Timing, valid question at this stage. You go File, New File, and once you have this new file, notice Run is on that option, you can now copy and paste a text file into this. So you can now copy a text file in, and it will execute it. Or you could type from scratch, either way.
Awesome, thank you.
Good, I'm sorry, I was not going to do that until later, but that's okay. That makes sense. Where you're doing it, that would probably be the easiest way to do it. Either you just open a PY file, or you go File, New, and either copy the text or else type your own code in.
So when you're teaching this to the kids, though, do you have them just open the file, or are you having them type this in directly for the beginning?
Well, at the very beginning, when we're doing this very elementary stuff, we're kind of doing it together. I'm sitting together with the screen and pulling it off. Because it depends on your kids. I just know that if you have 30 kids doing this stuff and they're doing it independently, that means 25 of them are not doing what you're doing at all.
Right. No, I'm actually trying to project this to online teaching right now.
Oh, yeah, yeah. Yeah, in this situation, we're pulling this off, and I would just have them, after we discussed it on the whiteboard, showing them this stuff, then I would say, open up this file, and now let's execute it. Either open the file, depending on your structure, you can hand them as you go and say, here, I've just shared with you guys this document. Let's copy and paste and do it.
Right.
Or let's type it in if they're quick enough. It just depends on your audience.
Okay, we're probably going to do asynchronous, so I'm just trying to think of it in a different way here.
Yeah. Okay.
Okay, dokie. Yeah, middle schoolers online on a synchronous Zoom is not a fun thing.
Yeah, the whole bit. Yeah, it's, as you can see, even with us as adults, we got stuff going down here, much less with kids. Yeah, I understand. Now, on here, what would we do next?
Don, I have a question. Sorry, what is our eventual goal here? Are we trying to go from square to or are we trying to accomplish that very beautiful symmetrical figure? Let's see, where is that? In our intro session outline, are we trying to draw that complicated figure?
That's what we're trying to do. We're trying to create this right there.
Okay, so when you're asking us so I'm trying to imagine being a student in your class, and when you say, what are we supposed to do next? I might even say, hey, I don't see a square there. Why did we even draw a square? So, right?
If we had more time, that would be a completely valid thing. You're right. Like I said at the beginning of this, it depends where they're coming from. You're 100% right. And matter of fact, what's cool about this is that the kids who said, I see a square, I would say, where, why, how? And they would come up to the board and they would draw the stuff, or online we would say, where are you seeing this? And they would say, oh, in the middle here, we have a square going, you see, and even with that. So 100% agree. Seeing a square is not the natural thing. And if this was a natural sequence of discussion, it would definitely not be. What we are doing is a radically faster pace than you would be able to do this with your kids. And it depends on your level. If you're doing this, if I'm doing this from an intro AP class, we probably would be doing it. Although my class would be raising their hand and say, oh, look, but I see a square, but I could do it this way. And I say, cool, would it work? And then we would brainstorm that together and say, oh, well, yeah, but. And that's the game we would play. So I agree with you. They may not see the square at all, and they may actually see a completely different approach. One kid said, oh, I would have drawn a circle in the middle. If you look at that picture, they said I see a circle in the middle. And then I said, oh, I never saw that before. And what would you do to get that? Well, they go, well, hold it. The other kid says, well, but it's not really a circle. And if you enlarge the screen, and I could do that easier when we're face to face, but when you enlarge the screen, they go, oh, yeah, that's not quite a circle in the middle. It's like a 20-gon. It's not, it's not that. And they go, oh, shoot, now I see it. And we play that game. But others would say, no, I'm seeing a square right there. And we'll talk about that in a second, because we're going to run into some struggles too. Good. Other questions? Okay, now this is where we come in, that we say, hold it, all right, now what we want to do is, we want to pull this off, and this seems really inefficient. I like the kids. If the kids are responding, they go, yeah, I would say, how do you type this code in? The question earlier about them doing it, I say, okay, let's do it. So they're all typing away like crazy. And I go, hold it. This is taking too long. As we get this more elaborate, I say, what would be the smart way to pull this off? And what are the kids' response? And try to think kind of like kids. What are they going to do instead of typing all this stuff in? What would the first, I call it smart and lazy approach be? At
Copy
least.
and paste.
There we go. At least copy and paste, right? The kids go, oh, shoot, I didn't think about that. And they would copy and paste. And I say, great. That's fantastic. That makes it easier. I said, but later on, we're going to do some really elaborate things. I want to let you create an 80-gon. Would you want to copy and paste this sucker 80 times? And they go, well, no, that would be stupid. So I say, well, what do you want from me? Matter of fact, you will discover if you take the Wednesday class, one of the first things I do, teaching looping structures, which I think almost all textbooks and online things do an insanely crappy job of. That's why when we correct AP exams, constantly kids are using the wrong, let me rephrase that, the radically harder, more error-prone loop structure to solve problems. And they will make crazy mistakes because they never learned they're using a ball peen hammer when I need a claw hammer to do this job. And the fact comes out to be is that we haven't set them up in the right way. And I'll be showing that tomorrow. We'll be talking about that. So in this situation, what would make it even easier than copying and pasting? What tool might I teach you that would make this thing a lot cleaner?
If we could repeat or loop
Yeah,
in minutes.
right? Yeah, there's redundancy. And in fact, with you guys, with the kids, I say, what do you mean? Right? Why would I want to do that? Or what's the visual cue that says, or mental cue that says, aha, I'd want to repeat or loop something here. When I look at that code, what tells me I should have used a loop?
If you have repeated commands doing the same thing.
There we go. And if you've ever coded stuff yourself and you are solving as you go rather than designing ahead of time, which we all do, you will discover there are times when you didn't realize there was going to be a loop structure here, And all of a sudden you look back at your code and went, really, that's stupid. There's 4 pieces of this puzzle. There's only 1 piece changing. I could have done a loop and just changed that 1 piece. This was crazy, right? And therefore, learning this early on is a radically good thing for them to start recognizing. As soon as I have repetitive code, aha, a loop. And so tell me, and don't try to think like a 5th grader that you don't know, or even high school that you don't know anything. What type of a loop you want me to give you? I can hand you a tool if you ask me for it. And in this case, what tool do you want from me?
Something so that we can make it repeat
But-
itself.
And is there anything unique about this one that you are smart enough to say, yeah, I want it to repeat itself, but there's something unique. I don't just want it to repeat itself a whole bunch of times. I
It
want
needs to
repeat it.
rotate.
Well, we'll get
So you
there.
need to repeat itself 4 times.
Right now, there's no rotation. It's that, right? I want to repeat itself 4 times. I want to repeat forward and right 4 times. So you know, you see what I'm doing? If you know anything about code, look what we've just done. You've told me what type of a loop we are going to use because you know that we want to do the sucker 4 times. There are other times I do a loop that I don't know how many times I want to run this thing. And we'll talk about that tomorrow more. If I roll a dice until I get a 7, I have no idea how many times I'm going to roll that dice. It's a loop, it's the same thing. I keep rolling the dice, but I don't know when I'm going to quit. Therefore, that thought process right there that we want to embed in them from ground zero is something that matters. When you correct AP tests, it's the most masochistic thing. Yeah, I want to go and spend my first week of summer vacation correcting 10,000 tests. My favorite job. No, that's just sick. But the fact came out to be is while I was doing it and getting the other stuff, I would be looking at all these tests saying, what did their teacher do that screwed them up that I can avoid? Because these kids are working way too hard to solve these problems and making dumb mistakes. What can I do to teach differently? And that's what was beautiful about correcting 10,000 tests a year. It made it cleaner that way. And when you're a question leader, you did that. So what do we need? We want a structure that will do it 4 times. All right, so the code that we can do is, and now that I've lost all mine out here, is here. Here is if you look at your code 2, if you're looking at hard copies, you full paper over. Are we looking at that screen? I don't know what you guys look. Am I got the right screen up showing you with the code?
Yes, you do.
Thank you. All right, I think so, but I got to talk to you, Kathy, about this Zoom stuff this way to see if I can see what you guys are seeing, because I don't seem to be able to pull that off or know how to do it. Here we go. So if you look at that, this is the structure when you have a loop and you know the number of times through you want to do it. It is called a for loop. And yeah, if you've done any other computer programming languages, you go, yep, I got it. Now, the beauty of this is it all makes sense once again, like most languages do for for loop. In Python, the for loop is a loop I use when I know how many times I want to do something before I do the loop. So in this case, you wanted to do it 4 times. So if you'll see it right there, it's got the parentheses 4. That tells me I want to do it 4 times. And it says 4. And if those of you who got the code, you're looking at it, it's color coordinated in a really effective way. I like it. Python does it even more effective than most languages, or this Python's IDE does. So the for and the in or an orange, they're reserved words, and you don't want to be changing those suckers. The range is also a reserved word, but notice it's in purple, and there's some things you can do with that later on or do other stuff which you probably don't want to do, but you could. And the block stuff is the stuff that you pick. So it's, you pick a variable for, in this case, we did the square. So I said for side is in the range of 4. There's going to be 4 of these suckers. And right now we don't need to worry about it, but those of you syntax, yes, it's 0 to 3. It starts at 0 and goes less than 4. So it's going, and by the way, Python later on Wednesday class, when they do this, you can do radically more powerful for loops. Python allows you a lot of variety. But for this, kids, we're just doing it this stage. So 4 times I want to, and by the way, the biggest mistake is forgetting the colon. All constructs use a colon at the end of them to say what we've got. Those of you who do other languages, you will also notice, and we talk to the kids, that indentation matters in Python. Some languages it makes nothing. In C++ and Java, and C, you have to use open brackets, close brackets to surround the code, to embed the code. In Python, it is spacing. And so if you were typing this in, and I will do that below for the people doing it. So if you did for num in range of 20, and did colon, the cool thing is, as soon as I hit indent, return, it automatically indents to the appropriate place. And then I can type where I want, and if I hit tab, enter again, and it indents, and it will keep doing that until I hit enter and do backspace. So everything embedded in a construct, in a tool, is indented, and everything indented is embedded in that tool.
So the one question I have is that the word side, we could call it anything we wanted, you know, for
Absolutely
George in range.
Correct. Yep, exactly.
Okay,
correct.
so that's kind of a variable that we're putting in there?
Matter of fact, that's exactly what it is. It is a variable.
Okay.
And matter of fact, but the only thing I have for my students, and you train them early on, is that if you've taken CS at college, or you have students who are there, one of the professors who don't have to grade any code, they just let their TAs do it, always do massive internal documentation. As a matter of fact, I had students send me, because that's one thing I ask from my former students. I want to see copies of your old tests. I want to see copies of your code and say what the professor's comments are on them, so that I make sure that I'm teaching what you guys need. So if the professors have all of a sudden started to approach this in different ways, what I'm teaching at high school matches what you are having to be doing there. And one place I decided I am not going to match was internal documentation, because some of them had literally, quite literally, a third of their lines of codes were internal documentation. And the codes were unreadable. They were just, there's no way to find the program. Because the professors never corrected a single program in their life. They had the TAs do it, and they didn't do it. They just ran the code and see if the results were correct, and maybe checked 1 or 2 algorithms to see if they were doing the style. That's why students were using hash maps rather than tree maps, because they were just doing something to solve a problem, not choosing the right tool. So in this case, I always have variables. I tell the students from ground one, pick variables that mean something. If not, I'm going to ding you. Later on, when I start grading codes, I take a half a point off. Every code's worth 10. I take a half a point off for every variable that doesn't make any sense to me. So you'll never use X and Y unless it's a coordinate.
Okay, doke. That actually makes sense.
All right, good. And you train them from the beginning, it'll just be natural. Yeah, got it.
It might be helpful to switch to camera 1 so we can see and watch you talk.
Oh, okay. I was doing that code. Yeah, you guys got that. Okay.
But we can see you and still see your share screen. If you switch to camera 1, see you and then share screen, then we can see you and your screen.
Oh, I see what you mean.
Now share screen.
You don't want to look at the whiteboard?
Now share your screen. Now we can see you and your screen.
That's true. So you see all my meaningful gestures. Yeah. I
very animated. You don't want to miss anything.
Yeah, of course. Yeah. You want to laugh at me. That's what it's about, Kathy. I understand. So here we go.
You got it.
All right. Now, once we did this, everybody see this. If we do that, it produces the same results. And the cool thing is that it will save automatically every time. I love Python, the IDE. It'll force a save on you if you edit anything. And there's our square. And it did the same thing, but drew it for me automatically without that. Good? Cool. Now, next stage. What do we want to do?
Well, we need to draw another square.
Okay, but where do we want to put that square?
But it needs to be tilted.
Okay.
You don't want me to say where you want me to put the square.
Okay. So if you put a square, yeah. So if you put a square, we want to now change that square so that it prints out another square, correct? Now, here's where it's kind of interesting, the question people asked relative to, and I like that, relative to saying, was this a square, was it not a square, so forth. On our drawing, and now I am going to go Alt New and say, does that kick me to, it does kick me to the other screen? Yep. See, that's the thing, my Alt New doesn't work if I'm sharing. So I have to stop sharing and then go Alt New.
It's not done drawing yet.
And then go back here. Now, okay. Now I can go back to, yeah. On this, where in, so I drew one square, but I want to do that picture. So what am I doing now?
We
By
got
the way, where are we on the turtle? So here's our square.
excuse me,
Where is our turtle pointing? Because that matters big time.
to the right.
Yep. What, Mike?
Pointing
the
to
top.
right.
Yeah, it's in the top left corner pointing to the right.
Okay. So this is really important. And by the way, with my students, I don't enforce this too much and I let them stub their toe right here. Because some of them are thinking it's pointing up, they're thinking there's other, and that this matters for you guys, correct? Because it's going to change what occurs now. So if I want to create that design, what am I going to want to do at this stage in time?
Rotate that cursor.
I want to rotate the turtle one way or the other, correct? So
Correct.
which way, and by the way, there's a whole lot of answers here. Once again, as someone said, I didn't see a square, I would have seen this. We would have played with those if we had the time to deal with that structure. So in this case though, which way do I want to rotate it?
Well, go the same way you went before because you have little kids, so go right.
Okay. And what do I want to go right with? How much? What do I want to do with this turtle? As a matter of fact, depending on the age of the kids, the younger kids, it's kind of cool. I love that. The Mike's noticed this, we talked CS together. I love the fact that my intro class, which were freshmen, at North, a huge percentage of my freshmen, we had a prerequisite which required them to finish Algebra 1 to successfully complete Algebra 1 before they did our programming. And we're a big enough school, we can pull that off. If you're in middle school and stuff, that's not going to be the case. So here, we just say, where do you want it? I want to turn it a little bit. The cool thing is that there'll be somebody in that class, that group that knows geometry enough to say, oh, that is, I'll move this a little bit here. So then you, is it still,
20 degrees about, I think.
yeah, yeah. See, some kids will not know what 20 degrees is even, and others will. So you rotate it, and then you'll have somebody in the class who knows angle measurements, and they can help the rest of the kids. They're teaching them some geometry already, even if this is 4th or 5th grade. Although we do geometry embedded in that frequently, they already have that concept down. So now what do I want to do?
Now you want
I
to repeat
rotate
that
it.
first loop.
Yeah, you're gonna draw another square.
I'm going to draw another square, right? I would draw another square, and I'm pitiful drawing here. So we do that, and then
Do it again.
do it again, and do it again, and do it again. Ah, oh, hold it. Okay. If we're seeing that, if we're doing that stuff, if we are doing that, we are drawing a square. I say, this is where I do the hands-on. So our algorithm is we're drawing a square, rotating it, drawing another square, rotating, drawing another square, rotating. Aha. So obviously what tool is going to be beneficial again? Rather than doing that a whole bunch of times, we're going to use our loop.
Our loop.
Right? So therefore, if you guys look at number 3, smart square, and by the way, I would not, once again, hand this to them.
Don, what's the command to speed up the drawing?
Oh, good. We'll show it here on this one. Thanks, Mike. The command is speed.
Oh, speed.
And in fact, I have it right there. If you look at right above here on the turtle, not on the printed out code, but I did write it on the actual syntax I think you guys got. It is T1 speed, and it goes in a range, I believe, 0 through 10. Oh, let's just do this instead of me telling you. This is the other thing. Those of you who are talking about wanting help or some under help on Python's help, they have phenomenal tools. If you want help with the IDE, they give it all to you set up. If you want a Python doc stuff, you want help about other things, there's Turtle Demo that comes up with a whole lot of really cool codes, and you'll see later on that I've stolen a lot of them in many places. If you want docs straight from Python, you click on that and it will take you to an entire tutorial where you can pop in any command you want, and it's a real good search. And they actually, unlike Visual Studios, you can actually read it and understand what's going on. So you can actually teach yourself just by using their online tools right there, if you have background already. So speed there. And so if I run this thing, we'll talk about a couple pieces of that in a second. See, I changed something so it automatically made me, it'll pop it out fairly quickly for you. All right. Now, before we got to that stage though, there's a couple pieces of this puzzle that I would not be handing to the students. And you look at this, and what are the pieces of this puzzle that they should have figured out as we were drawing this picture?
You've got some new variables stuck in there.
Yeah. Because what did we do instead of, and this is the other part of it. So here is our loop. There's our for loop that we did to make one square. Correct? With the students, we would not dive into this and show them this code at all. I'd be having them all together. Our lab at North, I loved having, and I'll be honest with you, as soon as and you may or may not have the capability of doing this, it all depends. We lucked out, they built a brand new addition, and I had a principal, one of the two rare ones that I've had in my career, three, but one was overseas, that actually talked to teachers and asked us our opinions and actually followed them. It was a unique combination. But she came to us, Mike was there too, and said, with this new, she sent the architects to talk to us to say, what did we want our room designed like? So that we could actually design the room to fit our needs. And I always think, as soon as a kid's hands are on the keyboard, they ain't paying any attention to me at all. Unless I shut off all the monitors and play that game, they're doing their stuff. So we had desks in front. We would always have our discussions in front in layout and design stuff. And then all the computers were around the peripheral room and all the monitors were facing me. So I could stand up front. I always taught you guys, I know we are that way. I would have to have 30 kids in the class or else they would cancel the class. Well, you don't have 30 kids taking AP Computer Science at the beginning of teaching this stuff. So I would teach 3 courses in the same room, 3 levels, past the Java 1, Java 2, Java 3. And they would be doing different things. And they'd be teaching one group and the other groups would be around the outside coding. And then I'd be flipping groups in and out relative to working with me. But I could see what was going on in the monitors all the time. The interesting twist, one technique that I would recommend to work great for me at least, was when I finished giving a problem, I would say, all right, you can start coding, or we could sit here and discuss this, brainstorm some stuff first. And it's kind of nice because Fantastic Four has come in, otherwise this was a real old illusion. But if you know I think it was Dr. Stretch, what was his name? The guy, Fantastic Four guy who stretched rubbery guy. I can't remember. I think it was Dr. Stretch, wasn't it? Or Dr. some other name. But soon as you're starting to give a problem to your students, before you have even finished the words out of your mouth, the guys, several of your guys, are already coding the answer. They don't even know what the problem is yet. They don't have, you haven't even said the whole thing, and they're already typing code in their brain and or physically, if they could, they'd be doing it. And you say, good, you may leave. Right now, there's a problem, go ahead. But if you want to sit here and we want to brainstorm a little bit, let's go for it. And we would talk very quietly. I know that may be hard for you to believe that I can do, but we can. It's nice you have volume controls on your side, so you can deal with that. But we would talk, I say, we don't want to, we don't want to bother them. Plus, we don't want to give them any of your ideas because they don't want to listen. So what do we do here? And we would sit and brainstorm ideas. And we've been doing like we're doing on the whiteboard. And I loved it because if you could conjecture what, and we worked at North, really was cool. We ended up having close to 50% young women involved in our courses and a huge amount of diversity. But we would say, you can imagine who was up front. Think about that for a second. Your population may be different than mine. I know what mine was. And we would be sitting there thinking about it. And we would talk through this. And in 10 minutes, we could cool anything else. No, don't do it. And they would all go and work and they would get their code solved and prettier and more efficient and the best stuff. And gradually it was funny. More and more of those Dr. Stretches stayed up front for a little bit more because it actually paid off. It was fantastic. I love them learning their lessons on their own. And others got C's because they never got a code that worked correctly. So here we go. So in this situation, we do the same thing. Notice we now need to say, well, what are the questions you ask? Because you would not jump to the code this way. What would be the first question you would ask your students after you did your for loop for the square to make one square? What would the next piece of the puzzle be if I wanted to create this other stuff? If I'm now doing the graphics thing, right? What do I have to do to make that picture? Right? We talked about
Oh, I lost it.
this. It's coming back. It'll come back here. That's just switching screens, right? So we made a square. Now you talked about rotating. What do I have to answer or think about before I can put that draw square, rotate, draw square, rotate, draw square, rotate, before I put that into, now, by the way, I could have copied and pasted it until I found this out. That's actually a legitimate approach to this, right? But if I'm smart and lazy, I think it through first. So what do I have to do with that picture before I can write my loops?
Count.
Yeah, that was a question. Yeah, here we go. So here we go. But by the way, I love it. I actually like teaching. Teaching adults is radically harder because none of us wants to look like an idiot. Teaching adults, I taught in Korea for 4 years. Teaching adults is like teaching Korean students because they never want to answer a question unless they are 100% sure the answer is right. And we adults
No
are that
problem
way
looking
too.
like an idiot.
What's that?
I have no problem looking like an
Yeah,
idiot.
but fortunately, well, never mind. I won't go that way. So here we go. They don't know me well enough to know our repertoire. But here we go. But the fact comes to be, yes, I know that feeling. We don't want to do that. But in real life, the questions we ask, no one knows the answers. And we're doing this real. We don't have, and it took the hardest part for me to teach in Korea was to get them past that border. And thank God I had an insanely brilliant young woman who wasn't afraid of asking the questions. And everybody in the class, my advanced class, knew she was the smartest one there. And since she was willing to risk it, they jumped into the fray. And it made the class phenomenal. But we have to set our kids up ready to do that. And yes, people alluded to it. Doing this online radically makes that harder. Because how do we do the interaction and the people asking questions? It's far easier online just to not click that unmute button. You have to do 2 steps to be able to talk in this situation. And you don't want to override everybody. We're all polite and we don't want to look like idiots. So it doesn't happen. Okay.
And then you've got a district that does asymmetric, which
Yeah.
means we're not online at the same time.
Yeah. And so, and there's other issues relative to that. So, and also sometimes the questions are too easy, but once again, for those of you who want, the Wednesday will be different, then we'll go past that at a different pace, but we have to do all the stuff here. So how do I know how many squares we have? We have to count them, right?
Yeah.
And that's
what
someone
you
alluded
asked?
to. What's that, Mike?
I'm sorry, but I couldn't figure out what you asked. That's what you asked, was
Oh.
how many squares? Okay.
Yeah, well, somebody said, I said, how many times we're going to do this loop? Someone said, count them or something or other. Because we had to do a square, rotate, do a square, rotate. And I said, and you say we could count them up. And I'm not a very visual person. I'm not artistic. My wife is phenomenal that way. Thank goodness that's why it works well. She takes care of all those. And so you could do that. But the cool thing in a classroom setting, there's somebody who either analytically could do it or visually could do it.
Well, yeah, we did 360 and we divided it by 20. So there's
Well, there we go. Now there's the other one. By the way, that's what I was going. That's the way we do it. That's why I do it. I knew Michael was going to pull that off. There's the mathematical stuff. But since we rotated our angle chains of 20, if on the code you're looking at that paper-wise, if we're doing the angle chains of 20, now, by the way, Kathy or anybody else, how can I can flip screens, my camera. Is there a trick to flip? See, I got dual monitors here. Is there a way to flip sharing with you guys, or do I have to just stop share and go back to share with the other screen? I don't know how to rotate that. So now I'm back to the code screen.
Yes.
Is there a way to, like, I know the hotkey alt in for cameras, but is there a screen, anybody know, Zoom? Okay.
Not that I know of, but we can look at that later, Don.
Well, I tried, didn't find it. So if someone knows, cool. So we look at this code, Mike, if you look at the code, either paper copy or here, we have the 20-degree change. So we know, and matter of fact, there may be the fifth graders, I'll be honest with you, one of the fifth grade kids came up with it. They said, oh, well, we got 20 degrees and a whole circle is 360, so we must have rotated, and we did a constant in there at this time. Instead of that, we rotated 18 times. As a matter of fact, we can do that here. Instead of doing this stuff, matter of fact, I'm going to, I'm just going to change num square to 18.
So for younger kids, it almost seems like there's another step program in between square loop and smart square.
Most assuredly. Yeah. And I'm just doing it here for timing relative to our conference and workshop. Yeah.
Because this seems like quite a jump for middle school.
A huge jump here. Yeah. And but I want to, relative to what we're doing. Yeah. So 100% agree. 100% agree. And so therefore, in this situation, the 18 is even a big jump. Either we would count them, or we would do the math, or we would copy and paste. For many of the younger kids, they literally, I would say, okay, what, and they didn't keep in mind, think about, you took a leap pretty quickly, but we did one loop because we saw redundancy. They don't automatically transfer that to the next step. So they would say, I'd say, how we do this? Well, we could do that. I'd say, how we do it? And they would copy and paste it. They would automatically do that until they would go, oh, hold it. We just did that a second ago. This is stupid. How do, and a couple of bright kids would automatically do it. Others would say, and then I'd have them help the kids beside them doing that. Once again, online stuff, this is tweaky. It's a lot harder to collaborate between them. But here we say, copy, and then how do I do this? I need another loop. And what's inside that loop? The whole other loop, and so it's got to be indented. And then tell me, looking at that code, what problem are they going to screw up? And I will put it first being 20 here. So they don't do that. Tell me what mistake, and by the way, this is the best way to teach AP prep there is, because those of you doing that level, because that's how I made all my multiple choice test questions. I had to make stupid, I hated, that was the worst part of the job. You had to make 4 sets of 40 multiple choice test questions a year. Think about that. And they had to be good because intelligent people were looking at them. And so what I would do is in the middle of class, as soon as I was teaching something, I go, oh, stop a second. And I would jot myself down on a note because that was a multiple choice question. And what were all the wrong answers? The mistake every student would make on these. So please tell me the mistake students are going to make with this code. This would work perfectly right here.
They'd screw up the indent for one thing.
Oh, perfect. In what way? There's multiple ways of screwing up the indent. Tell me, and we'll do it right now.
Well, that T1 right turn would probably be in that nested loop. So
Perfect.
Another indent on that one.
Perfect. Right? And that would be an insanely easy thing to do. Now, what you should be doing, I like that, Michael, because I can actually see you thinking. So here we go. This is why I wish I had the whole class. What would that do? What are the results? By the way, those I'm pushing this way ahead, but this is literally what you want to start getting them thinking about. And I would demonstrate this with the kids. tell me what you think the answer to this question is before I run the code.
So every time you do, you're starting to make a square. Every time you do a line, you're going to turn the cursor
How much?
20 degrees.
Careful. And right after I did it,
You're going to be actually doing it 110 degrees.
thank you.
Oh, that's, yeah, at the end of the line. That's right.
Yeah, do you see that? That's therefore,
Well, plus it's in the wrong spot.
but so everything, do you see it's all doing, but the cool thing is, this is where we could do this with fifth graders. That's kind of the cool thing. They are already thinking ahead and starting to analyze things in the way that we normally, we can't get them to do, because the answer is mathematical and they don't see the answer. Here I can run this stupid thing in 2 seconds and they go, oh, yeah, now I see what's going on. And so, yep, we should run it. And it would produce, and once again, I have to save, which is kind of a cool picture.
Oh yeah, that's kind of, it is cool. Yeah.
It is kind of cool. And we can use that later on. See, this is what I love. I always tell my students, the mistake on this answer could be the exact right thing for a future problem. And if you think about in real life, that's what we've got to teach them to do. In discussions at middle of Intel or the middle of Google, their wrong answers are wrong for this problem, but they may be the best answer. And I would have never come up with this answer 5 weeks later unless you had screwed up the question before. Unless we had a wrong answer, I would have never had this insight. Or you gave a wrong answer and I went, oh, that's not right, but we do this. And I would have never had that oh moment unless you had given a wrong answer that clicked my mind to see the right answer. I would have never gotten to that path. And that's not what textbooks teach. It can't. Online courses can't. You guys are the only way that this can get across into our kids' heads. You can't do it with anything online.
Yep.
Therefore, you guys are 20 times, 50 times, 1,000 times better than anything that's online, because you can do what we just did. But we have to think about that. And that's a little tricky. We don't. All right, so it was pretty and it's cool. Yep.
Can I ask you a quick question?
You
I
betcha.
noticed that you used RIGHT and you also used RT. Are those the same or are they
Yep.
two different things?
They are, as a matter of fact, on the, I think I put them on here. No, I didn't. I put the full ones here on the command sheet, but yes, they have abbreviations for, and once again, yes, people said this was a shortcut. That's one of the things in a general discussion I would, you could do FD instead of forward, you can RT and LT, and so there are shortcuts for most of the commands. So most kids pick that up. The cool thing is I rarely have to teach that, because you got some hot dog playing with the help files and they go, hold it, this works. And in 2 seconds, it's going to spread around the whole room. So I don't have to waste any time teaching.
See, for middle school, that's going to confuse the crap out of them that you've got to write in RT.
Oh, yes,
So,
100%.
again, I'm always thinking of my students, my sixth
Oh, that's
graders.
perfect.
and
That's
things.
exactly what we need to do, and we don't do often enough. I think that's one reason why online things suck so bad, is most of them either were never teachers or they were better at tech.
Well, unfortunately, I have to figure this out for my hybrid model where I've got them online for 3 days while I'm trying to teach them in class. So
we're all doing some wacko things. Yes, I know.
Don, I have a question.
Yes.
So you were just saying how you're not visual, and I can imagine a few kids who are just not able to break this down into those squares.
Correct.
So in the event that that should happen, is there a way for us to randomize the colors of the squares so that we can just show them a visual of that?
Yes. As a matter of fact, if you'll notice in the template, I had that import random. That is one of the variations. See, I have all my stuff I save files from every place I teach. So I do unique things every time. And my wife kind of hates it. She says, you taught this workshop 15 times, and yet you spend 5 days prepping for the same thing you've taught her. I said, but this is a different group. I have to do this. And it's nice that I'm retired, so she wants me out of the way anyway. So in this case, yes, you got import random. And where would I put that command?
in the loop, I
Yeah.
hope.
And so we would play the game inside the loop, and I'm not going to do it right now, but yes, one of the things, there's a homework, if you have time, that would be something I would recommend you look at the help files, because there's a way, colors are both words and numbers. So you can play with that. There's a hint that I'll give you. Someone ought to come back and share with everybody in the group. That's when you can do it. So yes, it would be located in the loop. And what would, this is, like, you know, I told you we get together and talk quietly. This is one of the things we would do. So where I would put the random inside which loop.
The first one,
Why?
because otherwise it's going to change each line.
And we don't want, there we go. If it would, now I put it inside the middle loop, the second loop, it would change colors of every line and would not help us solve what we're talking about, correct? So I would put it inside the first loop, because that's telling us how many squares to make, not making a square. And what will I want to do with that random, therefore?
Mm,
You're muted, Mike.
yeah.
I just have to say I have a 4-point buck walking in front of my window.
Oh, yeah. Mike's in a good place, and it's not a screen background, but yeah. So what ends up happening, you would change the random color, right? So I'd have to figure out some way to change the number inside of the color command. So it would be t1.color parentheses, and I could put the random command in there, or I could do a line of code that picked a random number in the appropriate range, and then put that variable inside the color. All right. So
Don, are the colors in this, are they in hex numbers?
only you, Michael. No, but you can. You actually, I think you can pick any version you want, but they do have integer versions of them, which is really
Okay.
nice. They're
So
actually embedded deep in hex, but
Right.
you have an integer, so you don't need to teach that garbage to kids.
Right.
And they are numbered off. If you look at the help files, they'll show you the number and the correlation and the range. So someone want to do that on your own and ship it out and share it to everybody. We can pull that off. Okay, so what is the second mistake kids are going to make? That is, the number one mistake was made is actually what was said, was just given, is indenting the T1 right turn 20 inside.
Well, the mistake I made was I rotated it in the wrong place.
Okay. Where did you rotate it?
Well, they have to set it up. Let's see, how do I say this? They have to initialize the cursor, and then they have to rotate it in the program. So then that needs to be a variable so that it can change every time.
Okay. Or it depends on the size. We've made it all, we did the most advanced stuff here to do this stuff. To do all these variable stuff, right? We did
Yeah.
the advanced stuff here. They don't need to be constant. They don't need to be quite this variable oriented, but you need to make sure you have it in the right locations. Other mistake common for kids is that they don't indent this for loop. They don't think about putting a for loop inside of another for loop, and therefore they don't indent making the square for loop. Some kids, therefore, and you may want to, especially with online stuff, you may want to start making more comments in here. So you may want to put, and where comments are hashtag, and this is loop to make a square. And then up here, and you'll notice when you do a comment, it prints it in red, which is kind of nice. Everything past the hashtag will come out in red. And here is to loop to make multiple squares. So you got to make multiple squares, and inside of that square, you got to make a square. And that's what we have, or whatever comment you want to have. So some kids, it is clear to do this. And if you do the hands-on, I always did hands-on pseudocode. So the kids in that group that's quiet, that sits in the middle of the room with me, when we have that capability, I say, what are we doing? And we talk this through and say, we want to make a square, but then we want to put that square inside of making a bunch of squares. And where do we want to turn it? We want to turn it in the making a bunch of squares, not in making the one square, right? I think that may have been relative to my perspective. Where do we put that right turn angle change? That's not inside making a single square, it's inside the other. Okay. Questions? And yes, we took a huge leap here relative to you that we would not have taken. We would have taken like 4 or 5 steps along the way if this was a middle school. This is even, we probably would have taken 1 or 2 steps if this was an AP prep class, if we did this. Those of you who have time and inclination, and even after this one, you want to listen to me again, which is, we're teachers, we are innately are masochistic. So if you want to do that tomorrow, we'll be doing the non-graphical components of this stuff. And if you were, what I'm showing here on Tuesdays, you could teach a 6 or 9 week session. I know some teachers have that like at middle schools where you do like samplers, the kids rotate through that. The stuff that I'm teaching you on Tuesday, if we get it completed, and I think we will, you could teach that entire 6 to 9 week sampler course using this graphical representation stuff. You could expand it.
You found out my secret agenda. I actually was planning to do that.
This is perfect. Or if you're doing a computer club after school stuff, this is ideal for that. I've taught it for both of those types of courses. If you're actually teaching a semester-long Python class or a intro to AP course, what you do is you'll take what I'm teaching you on Wednesday and incorporate that, intertwine it with this graphical stuff. So we would do a couple things relative to the math and this stuff, and then we would teach this for loop this way, and then I would teach a bunch of for loop examples that are non-graphical, and we would be talking about all those details. That's what we'll talk about tomorrow. And then we would move on to the if then and the decision stuff with the graphical ones, and then we would teach a bunch of graphical, if then and decision constructs independent of this. And then we would introduce other loop structures, and that's the way we would go back and forth between the two of them, using this as a tool.
Well, I appreciate this because I wanted somebody who's done this a lot with students, because then this is set out and then I can figure out how to make it hybrid and online without reinventing the wheel. So I do really appreciate this.
And that fits here. Please, if you feel comfortable, I would really appreciate, this is how you guys can interact with each other that we normally could do better because you're in the same room. If you do develop new stuff, number one, you can steal anything I've got. There's nothing out there that is worthwhile in any way, shape, or form. I'm open source completely. Please steal. If you adapt specifically what I have, please share both with me and other people, because I will steal from you. You'll see later on in the afternoon, the Wednesday class, there is a student, I did some challenging stuff relative to doing a binary search algorithm, and we did all that stuff. And one of the guys in the class did a way better one than I had for my code. So I've stolen it from him, and I've got his name, giving him credit right on it.
So I like the word share. I like the word share and collaborate other than steal, because
I like steal. Well, I just know,
I like steal too, because but yes, I get it.
I'm going to time out. I'm just giving Kirkwood the last 10 minutes, just letting you know where you are on timing.
Thank you. Fortunately, that is one thing I do have on my screen. So what we got. So please, and if you do create this like for your plot, you guys are going to have to tweak this more than any group I've ever worked with because of what you're having to deal with. If you come up with something that really worked, please share with each other and or share questions back and forth with each other, because there's no point of us reinventing the wheel. What we're doing is hard enough as it is. What we're doing is insane compared to other teachers.
This is still easier than taking my hands-on building engineering class online.
Yeah, that's true.
So that's, again, why I'm taking this, so that I can run something.
Okay. So in that situation, everybody with us, do you have any other questions or comments about that code? Okay. Well, what we've got next is what we will do. There's several offshoots here. One is, and I think I'm going to do this today just because we have a couple minutes to leave as a ending thing here for you to play with. What extension to this should we or could we do next? Extensions. There's several things now we could go next. If I did this with the students, we got to this stage, we did it in an hour and a half. They would take 3 or 4 or 5 days playing with this to get to this stage.
Different shape.
Ah, there we go. Matter of fact, if you cheated, either hopefully you did that on your own without
No.
cheating. Good. Do a different shape instead of a square. And what would be the simplest shape to go to, do you think?
Well, we've got triangles.
There we go, right? Go down size rather than up size, right? Especially with lower level kids. The cool thing is, now let's put it out there. Triangle is what, and matter of fact, that's what we'll start the class with next time. But think a second. You are your student. You've drawn, right? Let's go back to our brainstorming. We drew a line. What did we do to do a square? We turned right 90, correct?
Mm-hmm.
Now stop and tell me what you think, and I always couch it this way. What mistake do you think your students will make? Therefore, you can make the same mistake and say, oh,
They're
I would have done this,
gonna-
but my students would have done this.
It's exactly the mistake I would have made, is just change the range from 4 to 3.
Okay, you changed the range from 4 to 3. Cool.
But-
And therefore, would we have created a triangle? By the way, you can try these on your own. That's the idea. Would it have made a triangle?
No.
No, because
We're still turning 90 degrees.
we're still turning 90 degrees. Exactly.
I
So
would have
there-
made that mistake. That was the mistake I was just
Okay.
about to make.
There we go. So I'll go back to square loop. We would have turned, and so what's the next mistake we wouldn't make it, of course, but they would make?
The angle.
And what angle do you think they would choose?
They would choose the 60.
Everybody, and it would be natural. Almost every class I worked with, number one, if it's 3rd grade or 5th grade, many of the kids really didn't, they never transfer their knowledge they learn in math class, because we never set it up that way. They don't transfer that knowledge to any place useful. So in this case, we're asking them to use that stuff. And so they would say, some of them would get 60 because
Equilateral triangle.
there we go, equilateral triangle, and the internal degrees is 60, right? And some of you are going, well, yeah, that's the right answer. But the answer is no, because what would happen if they turned 60 degrees? And I'm going to have to get out of share here that way and change my, no, I can do that. And you said I can do that.
I say you got me on this one.
Did it? No, see, I can't change did it change you guys to my other monitor? I don't think it did. My other camera? No. Still looking at me. So there we go. I have to do
Oh,
that.
interesting. Because
Yeah.
I would have changed 60. That would be
Yeah,
my
that's what I'm
mindset.
saying.
See, I'll be the idiot.
That's perfect. I mean, that's exactly what we want to see, correct? Because this is real life. If you had done it, it would have drawn the line and then right turn 60 degrees.
That's going to be less than 90.
60 degrees, it's going to shoot off that way. This is fantastic for those of you who teach geometry, because this is the first time they would have ever
It's got to
used
be
it.
120.
There we go. And if you did this for elementary kids or middle school kids, think about how much better they will be when they get to geometry and start talking about jargon,
External angles.
external degree measurements, right? External angles. Because if I taught proof-oriented geometry for years, it's my favorite math class to teach, but kids never get it. I mean, there's a whole lot of kids who never grasp why we would even need or care about that at that level. But we need
I'm one of those.
Yep, there we go. And many of us are. We wanted, here's the turtle that was there. We wanted to turn going that way. As you can see, I'm definitely not an artist. So therefore, what do we want to do? We need to turn it all the way around And it's a great discussion to have with third graders or fifth graders or middle schoolers to talk about how does that work? How did we even get that measurement? Everybody see it. And what's cool is there's a whole bunch of things. So you're talking about, you then could be talking about supplementary angles and I mean, you're talking about all this stuff that you can talk about, which then when they get to it in geometry, all of a sudden they're going to be ahead of the class. I love teaching computer science to younger students because then when they get to the math class, they kill. It makes sense to them. Discrete mathematics is insanely that way. High school kids who did my class, and we did a whole mess of discrete topics. When they got to university, they were saying everybody was dying in discrete mathematics. To them, they went, oh, we did that problem back as sophomores. That's this and this. And they knew what it meant rather than trying to memorize something from a professor who was spewing information, not teaching them. Okay? So think about that as we're doing this. We're not only teaching CS, we're teaching a whole bunch of other stuff that comes along. So the last couple minutes. Is this, and please, instead of taking time here verbalizing, please send comments, email me, whatever else. Is this, and by the way, I know there's people who have more advanced stuff, and yep, this stuff, like I said, you may want to focus on the pedagogical stuff, or this may not be the group for you. I understand both of those. There's nothing personal here at all. This is your time. Two, though, is this a pace that we're doing that matches what you're doing, and is what I'm doing useful, or is there something other that I can interject while we're doing this? Please email me or let me know, or put it on the chat, and I will see those things later. I'm going to be going on to other shapes, and we're going to keep expanding this concept out. If we get finished this before the next 3 weeks, we will continue on to other areas, and you guys will have some flexibility. I'll let you choose, okay, where we want to continue this. But I have at least one more week of expansion of this, and maybe even a little more than that, okay? What else was there? Okay.
I have a question. The class tomorrow, is it the same Zoom link? Because I don't know if I got a Zoom link for the class tomorrow.
Kathy?
Yes, thank you for bringing that up. I will take that. So no, it is not the same Zoom link.
Oh.
And yes, I will be sending that information out this evening or this afternoon for the Zoom links for tomorrow. You will find that every Tuesday's classes are the same Zoom link, which was this one today. Every Wednesday, all the Wednesday classes will be the same, and I will be sending everyone a notice the day before every class.
Thank you.
So you'll get a nice email with the link, so all you have to do is click it and go for the next day. Yeah.
Yep.
And I
It's just
think,
a
did everybody get all the files? I've sent, since the registration didn't get separated into first, intermediate, and advanced and all that junk, I just send them to everybody. As I said, you can just throw them away or keep them and use them later on. Did everybody get files and documents? And I shared them, and then I also did them otherwise. So I was trying to cover all bases. So
I've got them for the beginning. I'm trying to figure out if I got them for the intermediate or not, but I'll figure that out tomorrow.
the zip file, I just sent that. I sent that later. I sent the intermediate yesterday because there was a bunch of stuff. The zip file does have everything put into one big zip
Yeah, I
file,
got the
too.
zip file
Okay.
After that.
If you got that this morning,
IT,
it's got all
yeah.
the things.
So everyone who registered for today is also registered for tomorrow. So I will send the link to everybody on that list. If you don't want to come tomorrow, don't. If you want to come, and Kirkwood, you had one more that signed up for tomorrow. So we'll add one more for tomorrow.
Now, you guys tell me, see, because I don't use, ironically, I don't use Google Docs and junk like that hardly at all, because I can do fancier stuff in the word processing that I use.
Mm-hmm.
If someone gets added to this thing, do they automatically get shared? If I share, how do I get them to have all the stuff that you have without sharing it to everybody one more time?
I can help you. I will do that together.
Okay, or you could share, since you have everything that I have, if you share everything to them, then because I hate feeling redundant to all you guys getting 19 email messages from me saying, you've got this information shared. You go, you idiot, I know that, I told you yesterday. So
welcome to Google.
I apologize for my incompetence. In Korea, we use completely different stuff, and at home I did other, but I haven't played with this that much. Okay. Great.
I can't speak for everybody else. This was perfect for exactly what I needed. So, I'm very happy.
And I
And
put,
others, I will take nothing personal if you don't ever show up again. That's okay. And Mike, I would recommend it, but that's okay. No, yeah.
can you hear me?
Yes.
Oh, well, I put the color coding in the chat because if you have advanced kids, that's a really good way for them to test themselves and also learn something for later, you know, because they learn about, they can use RGB or they can use hex or they can use text
Yep.
words. So it's nice to get them to learn those, know they exist.
Do you need quotes around the RGB?
You do. No, RGB. Yeah, I don't know. You need it around the hex value and you need it around the text.
Anything that has text characters in it, I know you need quotes. Mike would play the RGB. I don't play with that garbage at all. So
Does,
yeah,
And you need it around the hex because hex values have letters.
could have a text value in there. Yeah.
Yeah,
does it matter whether it's a single quote or a double quote?
it
No.
does.
Oh, does it, Mike? I don't think it does.
I answered too early. It does depending on your IDE.
Yes. There we go. Yeah.
Okay.
Some IDE single and double quotes are completely replaceable. And I don't know, the Python one straight up, I think it's replaceable. I don't know about the other IDEs.
Yeah, in my Pi, whatever it's called.
Hydroid? Yeah.
Yeah, it just corrects me to a single quote.
Okay.
Mhm. Yeah, I've just been using the idle
Yeah.
on the Raspberry Pi.
Yeah.
Yeah.
You're using a Raspberry?
Yeah, I'm on a Raspberry right now.
Oh my God! You know what? You know what? I thought you were talking about a real Raspberry Pi.
Oh, no.
No, I've got my computer set up here that I'm watching you guys on, and I've got a Raspberry Pi on a screen over here.
I was going to suggest Raspberry for those people that didn't, because it's a really cheap way, and you can then sidelong into robotics.
Oh yeah, no. Our school had a grant. We've got 18 Raspberry Pis. Actually, I used to coach robotics. I am not a robotics person. I am no longer a robotics coach. I prefer building other things.
Yeah, well, I mean, it's just, you know, it's one of those
Yeah,
things.
no,
where-
yeah.
We've got this for another half hour, right, Kathy?
Yes, we
Something
do.
like that.
We have another
So
30 minutes.
if you're, this is what we're done, but if you want to sit and listen and converse, this is perfect. This is exactly what, but I don't want you to have to stay if you've got something else going, because this is the time frame we set up. Tomorrow is from 1 to 3 in the afternoon. Let me know, pop in or out, and you're welcome to go back and forth depending on whatever is appropriate relative to your schedule. Okay.
I do have an ask before, if people are welcome to stay on, but if people need to leave at noon, I do have an ask before we let people go at noon. So you guys are the guinea pigs. This is our very first SuperQuest virtual. Kirkwood knows that he's been involved 30 plus years at OCSTA, 10 plus years for me. And this is our first online delivery of SuperQuest Summer, and it might be this way for the next year or two. So thank you all for being part of the experiment. And I am always open to making things better and more efficient, and feedback can come to me in an email. I'll be doing a survey at the end of the summer after we finish all of our classes. But for today, and for Kirkwood, you don't have to CC him if you don't want. You can all come to me and give us ideas, feedback, what worked, what didn't work, what could be better, what you want to see. Always welcome to making things a better experience for you all, because this is all about trying to help you all.
I usually talk more than this in a class, and people usually get annoyed with me because I talk a lot. That's why I'm a teacher. But I have to admit, I could never come to the summer ones because of distance. And
Right.
so this really, really helps me because I can actually now take these.
Right.
So I'm
Yeah,
very
that's
happy
true.
with it.
If,
I mean, it's a plus and minus, right? We miss seeing
Yeah.
you all in person because there's a lot of that networking and conversation that happens at lunch and before and after, and all those little micro conversations that, right, maybe people split off, but
Right.
we're going to try our best to be able to provide the network, the community, the collaborative work, plus, right, be able to watch Don make magic in these
Yeah.
in the
See,
hours.
'cause I've only come to one other one before, which was Vex several years ago at
Great.
South Salem. That was the only one I could come to.
if you got Zoom, I Skyped everything until we're doing this garbage. And so if you know Zoom tricks,
Yeah.
I played with it and did a bunch of stuff and I can switch screen. But if there's something that I'm missing that I can, like the alt new between cameras and alt in and stuff, if there's something, please share it with me, because you know, sometimes tweaking to shut off screen, stop sharing, go here. And if there's a better way, please tell me.
We're all learning together.
Yeah, this,
Mhm.
All right.
and for a first time, this went great.
And then I will stub my toe multiple times. So you're building the brick walls, or Kathy is, and she loves it. So please let me know. Okay?
So
All
we'll
right.
hang for another 25 minutes or so. If people want to converse and talk and visit, I will take the recording off. Or do you want me to leave it
Okay.
on?
Now, Kathy, just one point. On my recording thing, it didn't show up. I was
It's
worried about
recording.
that. I did think about you're showing up on Europe since you can. Good.
Mhm.
'Cause-
Can we get the text file after it's done recording? Because the text file for the chat's going to be different.
Yes,
If we could get that uploaded and shared, that way we can get some of that coding that's in there.
yes.
So Kathy, you'll do that for the times you're here, and then
Yep.
you'll show me how to. I probably can do it, but I'd rather steal your knowledge than learn my
Yep.
own. So,
On it. I'm on it. Yep.
great, thank you.
Who knows? We might even have closed captioning for the whole transcripts right online. So everything.
Yep. This
Yep.
this was awesome, but my computer geek son actually wants the bandwidth, so I won't be able to stay in chat, though I would otherwise. Hey, he's National Merit Scholar going to OSU in computer science, so I'm happy for him to be
Give it
on
to
the
him,
computer.
give it to him, yeah.
Yeah, you
Well,
should.
his his teacher, I don't know. Do you know Tagreed Emelouigi?
Yes, I know
Mac?
Tagreed.
Yes.
Yes, she's president of Oregon CSTA now.
Yeah,
she is,
Yeah, she's his teacher, so
Oh, cool.
she was
Very
his teacher for high school. So
Yep.
yeah, I
Awesome.
love Tagreed. We usually do a summer camp together, and we didn't get to
Yes.
do it this year for STEM camp, and
Yeah.
I miss her.
She's been great.
Yeah.
Okay.
So
Anything
I'm
else?
gonna log off and let him have the bandwidth.
All right.
So thank you. I'll see you
guys. I
tomorrow.
appreciate you
Bye.
showing up, and this is good.
John, I did hear you a couple of times kind of in and out. I think as far as you going back and forth and maybe doing the slowness of it all, it's not as quick as if it's just the two of us, but as we get more people, we just have to just hold our breath for 5 seconds.
Okay. All right. Like when I move up, switching cameras or
Yeah.
something like that.
Right, and when you try
Or
to
even
code,
screens.
Yeah.
Yeah.
or when you try to run something, when you try to compile
Yeah.
and switch back and forth, it takes a little bit longer than real time.
Okay.
That's okay. Just a little bit of delay.
And I'm trying to do a 2-hour thing, so I'm rushing more. I talk fast anyway already, and so now I get to make sure I mellow it out a little bit.
Okay,
All right.
a lot to say.
I have to go because Don's coming over for lunch.
Right?
Yeah, that's true. My
Clean,
wife picked up our lunch, and we're picnicking at his place. So here
Got a
we go.
vacuum.
Yeah.
We'll have a
Hey,
window
Michael.
between us.
Yeah.
Thanks, Mike.
Bye.
Anything else for the other people? I appreciate you guys willing to spend a couple hours of your day letting an old guy feel like he has something to do. So that's great. I appreciate that.
I was hoping that Mike would answer my question in chat about trying to call a variable inside the color command.
Oh, yeah, you can do that.
Well, I tried it and it doesn't like it, and I can't figure out why. Do you have some suggestions? I mean, I've gone through the documentation.
Now, did you
you made a thing
try a
called
number, or what did you try?
So I'm trying to, basically I created a variable that uses random.rand int and choose a variable between our number between 1 and 255. And then I put that in t1.color as the variable call, comma, call, comma, call. And
Oh,
It-
so you're doing RGB. That's what you're kind of doing.
that's what I was thinking of doing because it
That's
seemed
pretty random.
easier.
But they're
yeah.
all three the same.
Well, that's a question. I don't know if it's going to call that variable differently.
You have to review the random command every time you want a new random.
Oh,
You have to have three variables, call
Right.
RGB, R equals random, G equals random, B equals random, and
Got
then do it that way. Or just pick a random number, one of them, and it'll pick 1 to 255 in the color range.
yeah.
And it may be, and I'm not sure like you have to do that. You can check that. You may have to convert the integer to a string, and there's a string variable to do that. Or if you do the Wednesday class, and I'm not sure you're doing this, another way to do it, and it's one of the examples I do, you create a list of colors you want to use, and then you pick a random address in that list. So, and then you pick that out, but that's more limiting than what you're talking about. It's just an example of lists.
I'll keep plugging away and see if I can
Oh,
figure
there
it
we
out.
go. And Mike is a good one to ask. You're right.
It does seem like though that code should work. I'll play with it, and then are you going to be here for the tomorrow one?
Yeah, definitely.
Okay, well, I'll see you tomorrow. So I'll play with it and see like what, if there's something special you have to do. I'm going to use your code and see how to make that work.
Okay,
Okay,
thanks.
cool.
This is
Yeah.
great. I love this. Yeah, we could do this even we're doing this way. It works out. That's fantastic.
Yeah, that's neat. Okay, we'll see you guys.
I like Mike doing some work anyway, so that's good. That's great.
I know this retired thing is, doing a lot of work.
Well, we'll see you tomorrow.
All right, sounds great.
Yeah.
See you, Kat.
Okay, so
All right.
Jim and Debbie, anything we can
Oh,
help you with?
they're gone. Oh, no, Jim's still there. Yeah.
Anything we can help you with, Jim? Oh, thank you.
Oh,
All
he's
right, Don Kirkwood. Nice job. Congratulations. Nicely done.
Yeah,
It's not the same though, is it? It's just not the same as being in
No.
person.
but it's better than I thought. Yeah,
Oh.
it's better. There's more interaction. I can't, in
Yeah.
a classroom setting,
Yes.
the eyeballs, I can tell and I can call on people. That's what, we talk about as a teacher, what
Yeah.
makes good teaching is getting interaction between a lot of students.
Yes.
And I can go to their eyeballs and say, you got a question, Juanita,
Right.
what you got? And here, they don't even have their picture on the screen, much less me being able to look it through everybody and doing that. So there's deficits, but also the interaction was slightly better than I thought it was going to be.
Oh,
So
good.
that was
I
okay.
think it took a while for people to latch on, but after a while, right?
Oh,
Yes
yeah,
or no?
yeah. So
Well, that's what T was saying. This whole asynchronous teaching of having to
Oh,
record
yeah.
a video module and then having to, the whole reason you're a teacher is to talk to people.
yeah, well,
We're
that's
talking-
the relationship. Yeah,
It's that whole stage on the
Yeah.
stage thing all over again. That doesn't work.
nope.
Yeah.
Well, that's what they were correcting the AP computer science exam online. They were talking about doing that. And like 95% of the people said, I will not sign up if that's what we're doing. Because
Yep.
the only reason I come to do this stupid test is
Right.
to relate and socialize with all the people.
Yep.
No, I'm not going to sit home and correct papers. That's not
Right.
what I want to do. So,
Right.
yeah. But-
Right. So talk to me about camera. Don, tell me exactly what you're trying to do.
Well, what the issue, see, I could go between here with you now on this thing. I can go alt new and alt in, and then you are switched to the other camera.
Yep.
I can switch that. But the
Yep.
difficulty is if I'm sharing something, if I go to share right now,
Yep.
and I share my screen too with you,
Yep.
you are seeing that and you're seeing me in this picture. But
Yep.
I can now, if I wanted to leave that code up,
Yeah.
or you're on screen too, so you're seeing that stuff.
Yep.
And I wanted to go to the whiteboard, I cannot switch, I cannot go alt in. My picture is stuck on, no, it did it this time.
Right.
It didn't.
So now
do-
I see you. I'm sorry. I see the code, I see the board, and I hear you. But I don't
Yeah.
think I can
Oh.
see you and see the code and see the board. I don't
No,
think.
yeah, I knew we couldn't do all three, but
Right.
I thought maybe it was the delay. I did
Try
that
again.
alt in and then walked back there and it was still showing my picture here, so I didn't think it was switching to there.
Could be the delay. So try it again. So
Yeah, you're seeing.
Yep.
So you're seeing the whiteboard and my picture writ small.
I see your code.
Oh, the
I'm
code
trying-
big and the board small. Sorry.
Yes, but I can change my view.
Oh, you can change between them. Oh,
Right.
good.
Right. Because I can pin the board or I can pin the code. I
That's
have
perfect then.
control over what I see.
There we go. So that makes it, because now I can show either screen. See now, oh, here's why. If I wanted to right now see your screen, seeing my screen two,
Yes.
which is the words, right? On
Yep.
screen one, I have the code. If I go to there, I can't switch. Well, maybe I can. New share. It just takes one little step to do it. Now you're seeing screen one, aren't you?
Yep.
It'll take a second. Yeah, it just takes, there's no hotkey for me to switch between my screens.
Yes.
I have to go back to share and
Right.
switch to screen one versus screen two.
It's a little
But I
quirky,
can't
but yeah.
switch between cameras this way. Good.
Yeah.
All right, well, that's good.
You have to kind of be your little own producer there, but yeah,
Yeah.
you can do it. It just gives a little
Yeah.
keystrokes and some delay there, right? The more people we have,
Yeah.
the longer it's going to take to just get things rolling.
And I think my system may not be the fastest in the world, so maybe on my end, or it's just the mass group doing
Yep.
it. It just takes time. So,
We noticed that too.
okay.
Well done, Kirkwood.
Well, this was fun.
How
Yeah,
do you think? How do you feel? You feel good?
yeah, it was fun. It'll be interesting to see tomorrow's group coming in. We'll do more coding and stuff. But yeah, it was more effective than I thought it might be. So that was
Nicely.
good.
Okay, so the files that you want me to share out with the people for tomorrow, which ones? The zip code, everything
Well,
that so far?
If you, tomorrow, did you get the folder versions of stuff? I
The
sent,
zip folders.
not just a zip folder, that's just the code. But
Okay.
there's also a folder, I shared the folder of intermediate with everybody.
That was, yes, last night.
Yeah, last night,
Got it.
correct. So if that person, I think, because that folder has two subfolders, one
Yep.
is documents and
Yes.
one is code.
Yes,
So I think unless they request otherwise, and if they request independently, then I can just kick out the zip file to them independently.
got it.
But if you could just, so I wouldn't have to go through new people and check my list and do that stuff. If you
I'll take
could
care of
just make sure that they get that intermediate folder shared, that
Yeah.
takes code and documents, and we'd be happy.
Perfect. That's what I'll do. And today there were a couple of people who couldn't find it, so I just reposted the link in the chat while you were working,
Perfect. Okay.
and she was able to find it fine.
Now,
So,
the second part, if I add stuff to that share folder,
Yeah.
it is automatically shared because it's inside a shared folder. I don't have to reshare that in new documents, correct?
Right.
Okay. I assume that, but like I said, I don't do Google junk
That's
very
okay.
often.
It's
And this
kinda
is great. I'm learning it, so this is perfect. So
we're all learning together, Don.
I
yes,
should have
but no.
learned it a long time ago, but I didn't.
You just keep updating it, and right as soon as people click on it, they'll see the most updated
Okay.
source.
And what they do, they can edit it on their file, right? They're doing it, but what they do won't, because I've got the manager chart, they won't be editing the master file.
As long as you give them permission to do stuff and upload, they can.
They
If you
cannot.
tell them that they can comment or not change, just
yeah.
view, then they can't do anything.
And so you might check that. I think I've got it set up there for they can
Double check
add
permission.
their own and do their own, and they can share it with us. But I think I've got it, because I don't want them to go in ahead of what I've done and I load up a file that I saved and have that tweaked. If you
So
could
I'll
check-
go look, we can lock up your documents for view only so that they won't
Okay.
edit. They can't edit, but still be able to upload to the file, but not make adjustments or edits to yours.
yeah,
I'll check.
I would, I thought I had that, but I may not have. If you could double check that for me, and
I
if
will.
I didn't, talk to me
Yep.
tomorrow or Friday when we get together, we can do it that way.
So in the next hour, I'm going to send the Zoom out for tomorrow, as well
Okay.
as a link to that intermediate Google
Okay,
Drive.
perfect, perfect.
And we should be good to go tomorrow. I don't know what happened to the 10 other people. You had 23 people, you only have 13.
Well, it may be that those are in the intermediate class.
Could be.
There's two people who said that they wanted today, but they had, Woodward people had a big administrator meeting that they said they needed to go to. So I know two people said they would like to be here, but they may not today. They will join next week.
Got it.
But they may be the more intermediate group. Since
True.
I didn't get, early on, I asked them all and I got a list and there was like 5 or 6 people who specified intermediate.
Right.
But then the new registrants, I said, who cares? I'm just kicking it all out to you and do that. So we'll see tomorrow.
Is Mike coming tomorrow?
Yep, I think so. I'm thinking he'll be coming to both, which is really handy because he has
Yes.
great input and stuff.
So
Yeah,
he was awesome. So have him personally thank him for me, because that was awesome to have him worry about the tech side of
yeah,
Python
I
in the
know.
chat as you
Yeah.
were talking. So that was really helpful.
He's fantastic. I love,
He's great.
that's why it was so great working with him at North.
Yes.
We had permission. We were the only building in the entire district that did not have to connect up to the district server.
Lucky-
None of it.
Lucky you
Because
too.
Mike's internet, his Cisco class was building a server.
Oh,
And we said,
lovely.
well, the perfect thing is he should do this for real. They should have to maintain my material. So not only did they have a dedicated line for them, but
Right.
it was that, I know Mike knows about our timing, Chris, so this is cool.
Right.
Okay, there's my wife. Howdy, Kathy, this is Chris. You'll meet her Friday. Yeah,
Oh,
yep. I need to go to.
you have to go. I do
Yeah.
not want to keep you. I will
Oh,
see
no
you
problem.
tomorrow.
All right, sounds fantastic. Have a great one. I will end meeting for all.